Hello and welcome back to another video. In this one, I'm going to be doing a continuation of the multi-sig exercises that we've been doing. Um, Without further ado, I will go ahead and begin. I already kind of mapped out some notes here, so I wanted to kind of get that going here for you. See, in the last video, I believe we were using this folder here. So I'm just going to open that up. Let's see. I think because I have it open on the other side here. There we are. Alright. So I'm just gonna copy this, got some documents there, but for this one, I think I'm just gonna create another one. Here we are. Okay. Alright. So in this one, we're going to continue where we left off, and we're going to test out using the smart contract that we used in the previous example. We're going to use this smart contract and send a vote to pretty much get this smart contract, multi-sig smart contract, to mint some NFTs right down here. Or not NFTs, but ESDTs. For this one, I was thinking about doing it, but I haven't even really mastered the NFT mint per se. But I figured if we can at least get the commands going with ESDT tokens, that'll be somewhat like a stepped approach to eventually leading to more complex things like NFT. This is probably just more steps and procedures, but nothing that we haven't covered here I think would be applicable over here. So, we're logged into the one of the board members' wallets that we've been using. Okay. And we're going to go ahead, take a look at one of the features in this dev wallet. It's pretty cool is this token, mint token feature. And with the NFTs, I'll be doing the same thing too, but basically we just kind of test out setting up all the amounts here, right? And then, going through a sample, if you will, copying this. Not necessarily going to mint this, but it's kind of just the blueprints here to construct, right? Mm. Right. So from here, you can kind of piece together what everything is going to mean, right? So luckily I kind of cheated, so I've done this before, right? Um, here we are. So basically I extracted all this information here, basically by using this site, the Elrond converter tools. So let's see, convert hex to this, so right here, that was extracted here, so you can see dong is the result. So that's what that means out of the hexadecimal, and so on and so forth. You can kind of just break it down here. So that's the number of tokens. There's 12. You can see the 18 decimal spaces of the token, so you can kind of start breaking it apart. And I took the liberty of labeling the sections of this tool website of how to convert the hex to basically a human readable format. Um, Basically what you could do is essentially pass this in as well. And just keep it as is and use this as a template too. Let's see, no. Uh-huh. Or actually, I wonder why it's not working. It's supposed to be able to. Sorry guys, I do apologize. I'm just trying to figure this out here. There we go. That's what I'm looking for. What? There we are. Oh jeez, are you kidding me? Sorry about that. Okay. So using this, you can kind of piece together your your erdpy command with all the arguments here. So you can see how it's all kind of mapped out. Now it does take 0.5 eagle to mint, so we can see this here. 0.05 eagle is like one of the requirements when minting your own tokens. And it looks like it's using this smart contract too, which is the meta chain, I believe. So it's right there. And you pass in that issue command, so you can kind of see how we deciphered it. But we did make some changes here, right? So, it's all good. And let's take a look at our wallet real quick. You don't have any tokens in there, so let's see if this works. Not a valid file. Let's see. Whoops. Just gotta be in the right directory. There we are. So basically, it's just reconstructing a lot of the examples it gives you every time it asks to approve a transaction. So basically, it's taking your eagle, it's sending it off to smart contract, and it should give us some tokens if everything works out well. And there we are. You want to copy this here. But of course, you can convert all this to human readable format if you want. So, kind of piece it all together here. So, let's see. Alright, so the first argument's going to be that one. So we can do like string. Let's make it some other coin. Let's do that. String. Let's see. Something like that, right? And just pass in normal decimal number. Let's see if this accepts decimal too. String cat freeze. True. So oh, oh really? Let's try this again. Alright. Let's see. Yeah. 18. Can freeze. True. Can swipe. Can wipe. True. Can pause. Can mint. True. Can burn. 6E. Can change owner. Can upgrade. There we are. Let's see if this one works. So this was our first one, right? Yep. And there we are. So, alright. Basically figured out how to mint our own by the command line, right? So now, let's go ahead and use that example to go ahead and mint something off the smart contract, or the multisig. So, gather that we're sending tokens off to this meta chain with this command to mint tokens. So we're going to have to use our board member's wallet to put a request to the multisig wallet address to call this meta chain address. So there's 3 hops, and get the multisig address to make this call, and that everybody will vote in on to approve. It's just an extra layer, an extra step. So let's take a look. So what I did was I basically just kind of looked at this example here and pretty much replicated it. And for the purpose of this, I'm just going to go ahead and use the hex version of this, right? So, the address here was like this. So if we go here to convert it to hex, I'm going to go here. Oops. Here. This should match, and that's the thing about the metachain, the address never changes, so it should always relatively be the same, and I believe that's also for the mainnet too, but you should definitely check it out to be sure. So, there it is. Alright, and this is the 5 that we sent over, the 0.05 eagle that's required, and our wallet is currently holding 12, so we should have enough to send it off. And then here's all the same variables that we saw up here with the dong and whatnot. See? Right there. So this should contain all the same hexes that we saw. And let's send it on its way and see if it works. Proposed transaction. Oh, and then the one thing that we need to change though is the smart contract address. So it was from another example. So from Adam's wallet, the board member, he's going to send erdpy command to the smart contract address, which is this, calling the metachain wallet, the fees, and all the arguments to mint the dong token over there. So let's see if this works. While that processes, I'm going to also copy the string version. Let's take a gander real quick, see what we got going on. So it looks like it received it. Let's take a look at the vote queue number that we need to approve. What's this one here? Okay. It's the fourth thing to vote on. So 04. Okay. So now we need our list of approvers. So okay, so this is going to be 4. You remember you can use the hex down here too. The hex pretty much takes directly what is listed on the Explorer that we're looking at. Okay, let's take a look. Let's see there. Okay. Okay, while the vote goes through, just going to erdpy call. Okay. And we're going to call this wallet, right? And inside here, we're going to put the arguments. First one's the wallet. pass this directly. Oops. We use this as a number. Let's double check. Okay, we got our signatures. That looks good. No errors. Okay. Let's see, we have string. We got hexadecimal. Or hexadecimal. Interesting. Ah, there you are. This is the issue command. So after 5, string, issue. So that matches that. Okay. This should match dong. Okay, now it follows. Okay, so that will be the name, ticker, ticker. There we are. This is a number. Confirm that. If you don't believe me, hexadecimal. There it is. Yep, yep. Okay. So that, there, 18. Now we get into all the words. Boom, true, bop, 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 bop. Boom, true, da, 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 da. I don't think, well, it's dealing with e-gold. So why am I putting here this? Oh, you know why? Because this is from the previous command, so we don't need it. Let's see if this works too. Alrighty. Okay. Form all matches. I'm gonna approve on this one. There we are. So now this one's in queue while this is getting minted, so let's take a look. It's gonna be 5. There. No. Ugh. Alright. There we saw we got our first set of dong tokens, and the U logs should be coming soon. There we are. And there we are. Perfect. No errors, it looks like. And you can see we're using up some of the money here. Alright, let's take a look. There they are. There's our 2 tokens that this multi-sig contract minted. Alright, let's continue on. And now we're going to get into doing a multi-sig smart contract, sending the tokens. Okay. So, in this case, I'm going to take some variables here. Let's use Adam as an example. Alright. I wonder how well this is going to work if we don't get confused. Luckily, we have the hashes at the end different, though. See? But we're going to grab his address. And moving forward, I'm just going to try and use the string version as much as possible. Or yeah, if you ever want to convert it, again, you can just go up into tools and play around with this. That'll be this. And this will be the hex equivalent. Oops. We would use there. So, in this example, let's see, give me a second here. So in this one, I actually had to use a reference of another, somebody in the community was able to post an example of a multisig smart contract that was able to receive tokens, I believe, and I think, and you can see here that it's payable and readable, but you can see I was sending some stuff to them, but I was breaking down how they were sending their arguments over. So you can see that there, perform action, right? Go to the logs. So I think by reviewing all of this, I was able to see and weed out how they were able to send. Propose asynchronous call. There we are, so you can see how they constructed their arguments here. Double at signs, pretty much a 0 in there. So I extracted this and pretty much was able to mimic that. And I'll put this in the notes here for you guys too. So basically from that example that we got from that website, I pretty much was able to piece together, the wallet address, the zero, right? And the string and decimal numbers that are being passed in, right? This one we're gonna change though, because we have to match, this one. So let's go ahead and use this one maybe. Okay, so we are going to copy all the approvals, copy the smart contract address, change it out, ESD transfer, send the smart contracts dong token, that many, then okay, that looks good. Let's try and test it. Did it not come through? KLF. Oh. Oh boy. Just a hot mess right here, ain't I? Alright. Okay. One more time. This is our personal wallet and stickler. That's a smart contract career. We're calling. Third time's a charm. Oh, and I bet these ones were going to another smart contract, another example I had, but it's not going to be the board member. Cool. Alright. So, we got one here. Should be proposed to send something. Okay, again, it's just rinse and repeat. Rinse and repeat at this point. Granted, there's some small, sixth place, small things we have to take note of, change a little. And as these numbers go up, you'll see a difference when this becomes in the hexadecimal. The hex in the decimal. So we got the signatures, and now the actual perform action command. Here we are, looks like it did it. Yep, so we did. Perfect. Fantastic. Now, what we're going to do is the reverse. So, actually I should probably do this here too. So what I did was, for this one, I went into my personal wallet or the board members, and I practiced sending the tokens on over to them. That ours too. Um, so let's see if we can send them this one. Let's see if we can grab this as the constructor here. Let's give them a nil. See that? So I construct the same type of argument here. So that's the hex that we get if we were to do that, right? But I have to make some changes here. Now I think alright, so usually we would send this off, right? Watch what happens. I think we went into a snafu here. Arguments, ESD transfer. Okay, and I'm using Adam's wallet. Okay, but watch what happens here. Time. Oh, it sent it. Oh, B. Huh. It's interesting. That is very interesting because I don't think I put a deposit command in there, right? Oh, I did. Oh, alright. Well, that was backwards. But let's try it again. Let's get rid of this string right here and see what difference it makes. And this time, let's send them some U-log. Alright, so here's that failure I was talking about. You're like, why didn't it work? It did everything right, right? But if you look here and review the error, sending value to non-payable contract. And that's true because if you recall, the properties when we minted this contract, we did not pass the payable and payable by smart contract um, tags. So because we didn't do that, we have to play around with having this string right here, or passing this argument. And if we try this again, there we are, we have dong. Excellent. Okay. So that pretty much covers what I wanted to show you in this video. Um, it'll pretty much lead into the next section where I'll be discussing, this is the more juicier part, but having the smart contract that we have here, essentially use the MyR exchange. So instead of logging in with your phone app or your personal wallet, if you feel confident and comfortable, you can definitely use this smart contract to interact with it. There are some nuances to it too, so it's very tricky, but since we're in DevNet, we can just kind of play around with that and get acquainted with it. Real quick though, just to show you this, is something that we're going to be also looking at in the next video. But just to give you a quick peek at what it is and how to play around with it. It's right here. And I'll just, so basically we're just going to do the erdpy contract, right? So we kind of iterate through this here. And then let's see, I think we go into deploy, right? As we're deploying the contract after you draft it up, you can see these arguments right here. Let's see, gas limit, proxy, PEM file. Oh, here it is, metadata. Not upgradable, not readable, payable, and payable by smart contract. These will be the ones that would pass in, and we'll also kind of reintroduce the ERD JSON that we can have in here. So as we deploy smart contracts, we don't have to pass in these variables. We can have it predefined and always use those settings to kind of deploy the contract out. It's kind of like, I don't know if you ever worked with JSON files before, or VPN files, where you have to pass a username password that's stored in a file somewhere, pass the file into the command so it reads that file instead of having to manually type in the password in the command line, because of keyloggers and things like that too. So you can use the JSON, somehow erdpy connects to that JSON and reads off that JSON file and auto-loads all these parameters. And speaking of which, they also do have passing files in here too. I haven't played around with it, but I can imagine how it works. Well, that'll do it for me on this video, since it's during the weekday and I got work tomorrow, everyone. So, I'll go ahead and probably try to upload this, and then I'll edit, maybe, hopefully, by tonight. And then, maybe during the weekend, I'll probably have the third video for you up and ready. Well, thank you. Be sure to like, subscribe, hit the notification bell. Please leave a comment down below. Suggestions, questions, or anything you found interesting, or any enhancements that you think the Elrond team should do. And I'll speak to you soon. Thank you, everyone. Have a good night. Bye-bye.